Who wants to talk about fractions? I know, nobody does. But fractions are very important. As a matter of fact, I hear a lot of kids in class saying to their teacher, when are we going to ever use this math? Well, the answer when it comes to fractions is pretty much every day of your life. You're going to use fractions in some form or another. What if you want to bake some biscuits? Well, you may need to have 2/3 of a cup of butter. You may need a half a cup of chocolate chips. I know, chocolate chips and biscuits. Not too appealing, but okay. What if you have to double the recipe because you have a lot of people coming over? What if you cut it in half because you don't have enough ingredients? So fractions are just something we have to deal with from a practical point of view. And most of you can add, subtract, multiply, divide fractions. But the thing is, what really are fractions? What does a fraction mean? What does it represent? And so that's where some of us have some problems. So that's what this video is tackling, our basic understanding of fractions. And we're going to work with 2/3 pretty much throughout the video, but obviously this applies to any fraction that you have. The first thing I want to talk about is the fact that a fraction is part of a whole or part of a group. Okay, this rectangle represents one whole. And I'm going to divide it into 3 equal pieces. Okay, now in a fraction, the denominator tells us the number of equal pieces in the whole. And the word equal is very important. If the pieces aren't equal, then we can't model our fractions. And the numerator is the number of those pieces that we're going to focus on. And in this case, we're going to be shading them in. So the number of pieces shaded. So when I model 2/3, I take my whole, I divide it into 3 equal pieces, and I'm going to shade 2 of them. Okay, because each of these pieces represents 1/3. And now you can easily see that I'm modeling 2 out of 3, or 2/3. The whole thing is 3/3 because I'm dividing it into 3 equal pieces, and I would be shading all 3 if I were talking about the whole thing. So anytime you see a fraction where the numerator and the denominator are the same, that fraction is going to be equal to 1 whole. Now that's talking about part of a whole. The next example is part of a group. Okay, pretty simple. I have 3 circles here. If I want to model 2/3, that would be 2 of the circles out of 3. And that's pretty easy to understand. The next thing we're going to talk about is equivalent fractions, because if I have those 2 out of 3 dots, and I'm going to recreate that down here, what that could mean is it could mean a part to total ratio, meaning 2 out of every 3 dots are circled. What does it mean? It doesn't just mean that 2 out of a total of 3 dots are circled. It means every time I add another 3 dots, 2 of them are going to be circled. So this would be 1 out of 3. And if I added 3 more, you can see that I have circled a total of 4, 4 out of 6. And if I wanted to add another 3 circles, I would take another 2 out of 3, and that would be 6/9. Now, each of these fractions, 1/3, 4/6, and 6/9, are equivalent because each of those represents 2 out of every 3. If I wanted to show you kind of like the first model, what I could do is I could actually erase this and just kind of put a box around here. And what you would see is that if this was 1/3, 1/3, or 1 out of 3, it looks just like the model up here, but in this case, what we can see it as 6 dots out of 9. So because the models are the same, the fractions are equivalent. As long as we have the same amount shaded. We haven't taken any shading away, or we haven't added any shading. So those fractions are equivalent. They have the same model or the same value. Now, the flip side of that would be simplifying fractions. And why do we simplify fractions? Well, we find equivalent fractions if we want to add or subtract, but then at the end of our problems, we want to simplify. Think of money, okay? So would you rather have in your pocket 12 dimes or $1 and 2 dimes? Well, $1 and 2 dimes. It's simpler, it's easier to understand, and that's why we simplify fractions, because smaller numbers are easier for us to understand. So in this model, I have shaded 8 out of 12, or 8/12 of this whole thing, right? There are a total of 12 equal pieces. I've shaded 8. Now, when we want to simplify fractions, what we're going to do, and I'm going to try to do this without doing too much damage, is, I'm not going to, all right, look at that. So what did I do? I took away 2 of those lines, but remember the amount of shading is still the same, so that this 8/12 now becomes what? I have a total of 6 pieces, and you can see that 4 of them are shaded in. But you know what? I can simplify that even more. If I do this, guess what? We're back to 2/3, because now there are only 3 pieces and 2 of them are shaded. Now, we simplify fractions a lot when we do math, but we don't want to always draw a model. That's kind of ridiculous. So there's an easy way to do this, and we call it upside down division. And here's how it goes. I have a fraction 8/12, and I want to simplify it. The first thing I notice is that it has common factors, and that's how we know we have to simplify. So I look, and let's say, I know that they're both even, so I know that they have a 2 in common. Well, 2 goes into 8 4 times, and 2 goes into 12 6 times. Oh, you know what? 4 and 6, they're both even too. So they have a 2 in common. And 2 goes into 4 2 times. 2 goes into 6 3 times. And 2 and 3 are what we call relatively prime. And that means they have no factors in common other than 1. And so that is the simplified version. Now, if you took 8/12 and you right away saw, oh, they have a 4 in common, then you could do this in one step. 4 goes into 8 2 times. 4 goes into 12 3 times. These are relatively prime. And so here is your simplified fraction. Okay? And so those are just the basics. Of course, there's a lot more to know about fractions, but hopefully you